Hi Year 9. So today we're going to look at electron shells and understand what they are, the rules for them, that is to say the 2-8-8 rule, and we'll be able to draw them ourselves. So I'm really looking forward to this. I think it's actually quite an interesting part of chemistry, understanding the rules. This simple rule here that I've said, this 2-8-8 rule, which I'll explain more in just a second. This here can help us draw how the electrons are arranged for any atom and the first 20 elements of the periodic table. Okay, so the first thing that I'm going to do is show you the periodic table just to remind you. So you should see here, if I show you, there's hydrogen in the top left corner there, and that's shown in the bigger symbol as well as the example picture. And then if I go to this one here, in fact, you can then see there's helium in the top right corner, and you read the periodic table just like you would read a book. You start from the left at the top and you go across, and then when you get to the end you go down to the next line and you go across again. So you go from hydrogen to helium on the first line, and then you go to lithium, which is this one here, this Li. You can see the symbol there is Li, the word is lithium, and you read that along and go to lithium, to beryllium, Be, and then to boron across the other side of the gap, which is B, carbon, nitrogen, oxygen. So you can see here carbon, nitrogen, oxygen, fluorine, and neon at the end there. And these might not mean much to you, but what you can see is that the number at the top of each element, the atomic number, the example here being hydrogen, which has the atomic number of 1, that increases by 1 every time. So it's just like counting the numbers really. 1 for hydrogen, and then 2 for helium up here, and then it goes back down to the next line, 3 for lithium, and then 4, then we can go across, 5, 6, 7, 8, 9, 10, and then you can see that 11 is back at the beginning of the next line here. Okay, so the atomic number, that's the number of protons, just goes up by 1 each time, from hydrogen to helium to lithium and so on and so on. Okay, so you will need your periodic table today, so it's in your planner, page 115 of your planner, so I suggest you pause the video now and go and get your planner if you haven't got that already. Okay, brilliant. So you've got your planner now, I hope, and we can have a look at how we're going to use that to talk about today's lesson. So when I draw an atom, you should remember that there are 3 different types of particle inside an atom. We did that in the Connect. They are the protons, the neutrons, and the electrons. And so if I was to just give each of these a different colour, like say protons I'll draw as this colour, neutrons I'll draw as yellow, and electrons I'll draw as red. So if I draw an atom, such as lithium, for example, well, I could look at my periodic table, and we'll do more of this in another time, but I would know, for example, that you would have 3 of the protons in the middle, there would be 4 of the neutrons in the nucleus here, so this part here, this is called the nucleus, and then around the atom on these different shells you would find these electrons. Now the question for today's lesson is what determines where these electrons go. For example, why have I drawn 2 electrons on the first shell here, 1, 2, and why is the 3rd electron out here Why is that on a new circle around the nucleus? The answer to that is what we call the 2-8-8 rule. So the first thing that we need to do is work out how many electrons are we going to have in the atom in total. So for lithium, like I said, lithium looks like this. And it has an atomic number of 3. Hopefully you can find lithium, Li, in your periodic table now. And you'll see that the atomic number here is 3. What that means then is that it has 3 protons. But that also means that we also have 3 electrons, because the number of electrons and protons that we have in an atom will always be the same. So it has an atomic number of 3. That tells me that I have 3 protons, but I know then that if I have 3 protons, I must also have 3 electrons as well. So what is this 2-8-8 rule that I keep talking about? That tells me, the 2-8-8 rule, how many electrons can fit on the circles that go around the nucleus. On the first circle, on the first shell, here, I can only fit 2 electrons. And if I have any more than that, they'll need to go on the second shell. So the second shell can then fit an extra 8 electrons onto it, meaning that that would give up to 10. 2 plus 8, well, I would have 10 in total. But if I have more than 10, I would then need to draw a third circle here, and this would be the third shell. Let's look at some examples now, and we'll see this actually happening. Hydrogen is the first that we see and has an atomic number of 1. Therefore, its electrons, it only has 1 electron, and so it can fit it quite happily, quite easily, onto the first electron shell like this. The next example is helium. It has 2 electrons, and it can fit both of those 2 electrons onto the same shell, the same circle around the nucleus, like this, very easily. But lithium, we see the same thing again. It has 3 as its atomic number. That means it has 3 protons and 3 electrons. And so the electrons can't all fit on the same circle. I can fit 2 on the first circle, and then I fit 1 on the next circle outwards. And you can see here it's got a 2.1. I don't like writing it as a dot because I think it can get confused as 2.1. So I'm going to write this here for lithium as 2, 1, because I'm saying I've got 2 electrons on the first shell, and then I've got another 1 electron on the next shell out from the center. Okay, so if I show you what I'm referring to, this 2 means there's an electron here and an electron here. And that's the first number, how many are there on the first shell, and then the second number is how many electrons are there on the next shell, and it's just 1. Okay, let's then have a look at some more examples. So I'm just going to put these on the screen here, and you can hopefully see the same rule applies for all of these. Beryllium, which is this Be number 4 at the top, that has 2 electrons on the first shell on the inside, but then the remaining 2, they have to go on the next circle around, on the further out from the nucleus, and so we get 4 in total. Boron, the second one here, this green one, that has 5 electrons in total, and so you can see it has to fit 2 on the first shell on the inside, and then the remaining 3, they go on the outside as well. And you can see some more examples of that here. And if I scroll down a little bit more, what you can see, if I go past here, is that when you get to this, when you get to sodium, this has 11 electrons. So let's look at sodium in more detail. Okay, so we've got sodium. Let's choose a different colour. And that's got the symbol Na, capital N, lowercase a, and it's got 11 as its atomic number here. What that means is that there are 11 protons which live in the nucleus on that big blob on the inside, but there are also 11 electrons, and that's what's important for today. So instead of drawing lots and lots of different circles on the inside, instead of drawing all of these as this big nucleus, because it's good to do this, but it can take quite a bit of time, what I'm going to do instead is I'm not going to worry about this. I'm just going to write the symbol. I'm going to write the symbol for this element, Na, this here. I'm going to write that on the inside of the circle here. I'm just going to write Na in the middle there. Okay? In fact, I'm even going to do it a little bit lower down, just to give me that bit more room. And then let's have a look. This has 11 electrons. So I'm going to draw the first shell that the electrons could go on around the outside. And we're going to ask myself how many electrons can fit on this first shell. So you should be thinking to yourself now as well, how many electrons can fit on the first shell around the nucleus? And the answer to that is 2. So here I'm just going to draw 2. 1, 2. And I know that because I've got the 2, 8, 8 rule. That tells me that 2 electrons can fit on the first shell. Okay. Then I need to draw my second shell. Like this. Not a perfect circle, but pretty good. And I need to think how many electrons are going to go on this next shell. Well, it's not always going to be 8, because 8 tells me the maximum number that it can fit. The maximum number of the second shell. But in this case, I am going to fill it completely. And I'm going to fill it with 8 of these electrons. I'm just going to draw them in pairs, just because it's easy to keep track of them. So I've done 1, 2, 3, 4, 5, 6, 7, 8 electrons here. Have I drawn all the electrons? Have I drawn all the electrons for this diagram here? No, I'm still missing one. So I have to draw a third shell. I'll do it in black just to be consistent. I have to draw a third shell around the nucleus, so a third circle like this. And then I've got one more electron to do here. Okay, and how did I know that I had one more to draw? Well, that's because I'd already counted up how many I had so far. So if I just count them in a different colour pen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I knew at the beginning that I had 11 electrons because I was looking at sodium. So I had to draw one more for 11 out here now. Okay, so what I would like you to do is to draw the following. Can you draw for me boron, which has the symbol B, and it has 5 electrons? Can you draw what the electrons would look like for boron on the shells that would go around, around the nucleus like this? And can you do the same for nitrogen? So pause the video and have a go at these two in your exercise book. You should have already written your connect and your date and title. I'll give you the answers for the connect now as well. The answers for the connect were that protons have a charge of +1, neutrons have a neutral charge, that means they have a charge of 0, and electrons have a charge of -1. So those were the answers for your connect. And now I'm going to ask you to have a go at drawing the electron shells, drawing the electrons onto these circles for boron and for nitrogen, using your periodic table that's on page 115 of your planner. Okay, so let's have a look at this and let's work this out together and see if you got these right. Green pen this if you've made some mistakes, but if not, give it a great big tick if you've got the right answer. Boron has 5 electrons. And we know the rule for how many there can possibly be on each circle, on each shell, is 2, 8, 8, like that. So we're going to start filling up from the middle. How many electrons can we possibly fit on the first shell? 1, 2. And then how many do we have left over? Well, if we want, we could do the calculation for this. We just do 5 minus 2, and that would equal 3. So we must have 3 electrons left over on the next shell. It doesn't matter too much where you've drawn them on the circle. You could have spread them out evenly. You could have drawn them like this. That would have been fine. But I just like to keep them in pairs, just so I can count them a bit easier. And then I'll just check at the end, do I have all 5 of them? 1, 2, 3, 4, 5. Yep, I've got all 5 electrons. Excellent. So I don't need to worry too much about that anymore. Okay, and then let's do nitrogen. How many electrons does nitrogen have? I didn't tell you this one. You had to use your planner to find the answer. So I'll get rid of that to make some space. You should have found that nitrogen has, that's right, 7. Has 7 electrons. And so just like before, if I draw this out, I've got 2 on the first shell because that's all I can fit on the first shell. Remember, we're looking at this rule here, the 2, 8, 8 rule. And so how many do I have left over? If I've already drawn 2 of them, how many can I fill on the next shell? The answer to that one is 5. Okay, So hopefully you've seen those. Then what I'm going to do next is I'm simply going to give you a list of elements that I would like you to draw. I'm going to give you a list of elements that I would like you to draw, do the exact same thing as we've done just now, but then I'll just go straight to the answers on these ones once you've done them. Okay, so do all of these ones that I'm going to set for you now. Number 1 is going to be carbon. Number 2, beryllium. Number 3 would be neon. Number 4, magnesium. I'm going to make your life that little bit easier. I'm going to also give you the symbols for each one to help you find them in the periodic table. And I'll give you an example that the first one, carbon, has 6 electrons. Okay, and then what I need you to do now, is to draw the electron shells. Okay, so these were your answers. This is what you should have found for the 4 questions here. And just to check, just to explain how I got to each one very quickly, carbon has 6 electrons, beryllium has 4, neon has 10, and magnesium has 12. Okay, so here I count them up. I did 2 on the first shell, 1, 2, and then I had 4 left over. So 4 left over, and so then I had to go 3, 4, 5, 6, like that. Beryllium, again, I had 2 on the first shell, and I had 2 left over this time. So that was 3 and 4. Neon actually fills up 2 shells perfectly because I can get 1, 2 on this shell, and then look, I can get 1, 2, 3, 4, 5, 6, 7, and 8 electrons on the next shell, so that actually fills up perfectly. And if I count these up now just to check, I've got 3, 4, 5, 6, 7, 8, 9, 10. Now magnesium was the first one that I've shown you that you had to get 3 electron shells for. So this one we would write as 2, 8, 2, because that's how many there are on each shell. There's 1, 2 on this shell, and then there's 1, 2, 3, 4, 5, 6, 7, 8 on the next shell. So that's that 8 there, so 2 and 8, and there's 1, 2 on the end as well there. Excellent. So that's everything for this video. What I'm going to ask you to do now is go back to show my homework, and there's a link on there for a quiz where you have to work out what I've drawn, what's the name of the element or the symbol for the element that I've drawn on the quiz on show my homework. Thank you so much for watching, and well done again for all of your hard work.